Hello friends, so this is our problem of the day uh, 9 from GFG. So let's look in the problem. Okay, so you are given two 4-digit prime numbers num1 and num2. Find the distance of the shortest path from num1 to num2 that can be attained by altering only one single digit at a time. Every number obtained after changing a digit should be a 4-digit prime number with no leading zeros. All right. So let's understand the problem with an example here, right? Okay. Uh, Let me. Oh yeah. Let's, let's understand the problem first. Okay. So I want you to understand the problem first before doing the question. So we have given a number. We have given a number, right? And this is actually a 4-digit number. We don't have any other digit number. Okay. So this is very important. Okay. So we have given a 4-digit number and we have to convert this into another number which is given as 8179 by just uh, altering these digits, right? So suppose I can alter the first thing came in our mind is just alter the first digit or second digit or any digit. Suppose I alter 1, I alter, so altering means just change the digit. Okay, so altering means just change the digit as our desired digit. So I can do that, right? So let's alter 8 to 8. So I got the 8033. Then suppose I alter 0, so I got 8133. Then suppose I alter 3, I got 8173. So I alter 3 to 7. I alter 0 to 1, I alter 1 to 8 here. And then I alter this 9 to 9. So okay, so I got this in 1 2 3 4 steps, right? So this is how easily we got it, right? But this is not so easy. The question is asking to actually get into this number from this number by altering uh, exactly one number at each step. So in each step I can alter one number at most, but that is not important. The important thing is in every step if you alter a number you should have uh, 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 obtained a prime number. So by this what I want to mean actually is, suppose you want to convert this to a some another number by just altering any digit from this, right? But actually the question is saying you can alter this number, you can change this number to another number, that's okay, by altering one digit, that is okay. But the question is asking that the number you got should be a prime number. So based on that you have to change the digit. Okay, so if I change this digit to suppose I change this 3 to 4 and I got 1034. So 1034 is not a prime number, right? Because it is divisible by 2 as it has a multiple of 2 in its last digit. So I can change it to 1034 if I have to actually convert it into suppose 379 suppose what suppose 3791, suppose this. So what I try to say what I try to say is, you have given a number, right? You have to convert this number into another number by doing what? Alter a digit, right? alter alter a digit. So that is okay, but another condition is given which is very important. The obtained number, the obtained number should be prime. Okay, so you want to change it to another number, that is okay, but the number should be prime number. Okay, so now let's see the answer actually. So this number can be changed to any other number in various ways, because this number can be changed into 0 or 2 or 3 or 9. This number is also can be changed to 0, sorry, 1, 2, 3, like this. So we will got many numbers, but I want only prime numbers. So for that I have to change this digit 0. So suppose we know that I have to change this 0, this digit, and I convert it into 1733. Okay, then I will convert to this is a prime number. Okay, then I will change this digit and I will convert it to 3733. Then I will change this digit and we convert to 3739. Then I will change this digit and I will convert 3779. Then I will change this digit 8779. Then I will change 8179 by changing this digit. Okay, so by doing these steps I got my answer right. Okay, so that is the question is asking, right? So what I want to say is that there may be another ways to get into this number by altering the digits and getting a prime number, right? There may be another ways. So here the step number is 1, 2, 3, 4, 5. There may be another steps to get into this number which may be more than 5. So I want the shortest steps, shortest, how many steps which is short among all the steps to get into this number. Okay, so I want the shortest step, actually step number or shortest path to this number. Okay, so I hope you understand the question. Suppose I have, so what I have given is 1033. Suppose I have to convert this into 8179. So I will change it to some number, then I will change it to some number, then I will change it. So that's why suppose I got 8179. So I have to return the number of steps, and there may be another ways to reach 8179. Another ways where we got suppose 7 step, suppose 9 step, 11 step, but I have to give the least step number. Suppose in step 5 steps I got this number, just fulfilling all the conditions. Okay, so that is what we have to found. Now this thing we understand, right? So one thing we understand is the question we understood. Now we have to understood algorithm. Okay, so it's to find the prime numbers. Okay, so, or check prime number. So we know that how to check if it is a prime number or not, right? So we'll create a loop from 2 to up to the number less than that number n, and I will divide by that. Suppose I equal to 2, I less than n, I plus plus, and I will divide by I and check if this is equal to 0 or not. If it is 0, then I will break the loop and consider this as not a prime number, not a prime number. And for every I equal to 2 to n, if this is not divisible by I, and I will say that this is my prime number. So this is a simple algorithm. You can check it on YouTube, or I hope you know this, or you can check it on YouTube. It doesn't matter. But the thing is that there is another algorithm which is actually very tricky and also very fastest. Okay, so we have to know that. we can answer our question by doing that this process, but also I want you to know that algorithm also, because it is very uh, magical. Okay, so when I come to know about this algorithm, it's very magical algorithm. So what it does actually, suppose uh, I have to do the prime checking calculation for suppose 100 number. So okay, so now the number up to 100. So I am checking if a number n is prime or not, prime or not prime. Okay, and the number can be at most 100 suppose, or any x suppose. Okay, so what I will do, I will create an array of size x, right? I will create an array of size x, and I will put all of the here places by 1 or true. All are my prime numbers now. Okay, I'm saying once again, I will create. So suppose I have to find, or suppose I want to find that if 100 is a prime number or not. Okay, so what I want to say is that I have to check if a given number is prime number or not, and the number is equal to some x. So I will create an x size array, and I will actually put true to all the values, to all the array cells. Okay, so every array element is just denoting true, right? So everyone is now prime. So true means prime, false means not prime. So now what we will do, this is for number 0, this is for number 1, this is for number 2, this is for number suppose 100. So this place is actually telling me that 100 is a prime or not. This place is actually telling me that 102 is a prime or not. So initially 0 and 1, I will place it to false. Okay, so I am just filling all of them by true, then I will place these two places as false, then I will start a loop from here to here. Okay, and what I will do, I will check if this is true or not. So in the place of 2 I have true, right? So 2 is a prime number. So what I will do, the actually funny thing is that I will put false in every multiple of 2. So this is 2, this is 3, this is 4, right? So I'll put false here. I will create a loop and put false in every multiple of 2. So that's why all the multiples of 2 actually gone. I don't have to check them again. And that way, so then I will encounter by 3, right? So this is true. Then what I will do, I will put false to all the multiple of 3. Okay, so that was 5, 6, so I will put here false, right? So that's why. So then suppose 4 is already false, so if I got any true, 5 is true, so I will put false in every multiple of 5 except 5. Okay, so why this is working, because starting at 2, 2 is a prime, right? So from 2, 4, 6, 8, all of them are gone because they are divisible by 2, right? So how we before that, how we work on checking primes, we actually divide the number by I running from 2 to that number minus 1, right? So here actually that happens in another way. So I am actually checking 2 and doing false for every multiple of 2, then obviously I will get the next prime. It is obvious, right? So then I will keep this as true and give the false value to all its multiples. Okay, then obviously I will get a next prime number, because after that and before it all the values are actually covered with false, and the elements that are left with true are actually my prime numbers. So I get my next prime as a true number, and then I will put false to all the multiples of 5 except 5. So that is how working. So when we code, you will understand the code, you will understand this. Okay, so don't worry. So this is the thing, right? So we understand the question and we understand the prime algorithm. So suppose I create a three size array or 4 size array, right? This is for checking suppose Okay, so suppose this is for checking 0, 1, 2, 3, 4. So for this one, how does it work? So for 0, so firstly I am putting true values to everywhere. Then I will put 0 and 1 as false. Then I will check from 2. So 2's multiple are uh, signed as false, right? So these are false except 2. Now I got 3 as true. So there is no multiple of 3 right here because my array size is 5 now. So array size is 5. So see, actually I got the actual values this way, right? So 0 is not a prime, 1 is not a prime, 2 is a prime, 3 is a prime, 4 is not a prime. So I got actual values, right? This is an example. Okay, now what should I do? Is 1 a prime number? Is 1 a prime number? Let me check. No, right? So we have done the right thing. Okay. So now we have to do is we will do a breadth first search. Okay. So suppose I want to convert 10 into 70. Okay, no. I want to convert 14 to 17. So look very carefully. 14 in 14. So I cannot put 0 here. One thing to notice here because then it will be a one digit number. When I am working with 2-digit number, as in the question we were working with 4-digit number. So in 4-digit number, I cannot place 0 here. It will become a 3-digit number, right? So I have to check that condition. So in here case, I am working with suppose 2-digit number. So I cannot place 0 here. So my possibilities are, so the possibilities for changing this number into another number are as follows. 2, 4. Just changing the first digit. What are the possibilities? 3, 4 and 4, 4 and 5, 4 and thus 9, 4. And changing the second digit 1, 1, 1, 2 and similarly 1, 9, right? So these are the possible cases for changing 1, 4 into another digit. Now suppose, so for 2, so for 2, 4, let's check for 2, 4 now. So I can check 2, 4 into, so I cannot do this now to 1, right? So I have already taken this element 1, 4. So I can change it to 3, 4 and 4, 4 up to 9, 4. Then changing the second digit as you can say 2, 1 in this way 2, 9, right? So for 3, 4 I have many values, for 4, 4 I have many values, for 5, 4 I have many values. So you can look, this is like a tree. So this is my root node, this is my this is my child nodes, okay? And for each child node I have again many childs, right? So this will go up to like this. So 4, 4, then all values, 4, 4, then all values, right? Then 5, 4, all values, then 6, 4, all values, then it will go like 7, 4, 8, 4, then 9, 4. Okay, so this is the whole tree. So I cannot draw this tree like this, like so. This is very big. So this is the way it's actually working. So what I will do a breadth first search. So in breadth first search, if you don't know, just look into the YouTube for breadth first search operations or breadth first search algorithm. So what we will do, we'll put the 14 first, then we pop this one and add all the childrens. So it will actually work on the breadth first. So it will work on the breadths. Okay, so the breadths of the levels, each level. So this is my level, you can say 2, this is my level 1, this is my level 3, this is my level 4. So I will pop this one. So firstly I am just adding 14 and popping this one. I will add all the childrens, 2 4 3 4, like this. So all the childrens will be added, and I will pop the first children and add all these childrens. So like 3 4 4 4 will be added. I will pop this one, add all these childrens, pop this one, add all these children. So how they are working, I am firstly adding all the breaths, these breaths, right? Then I am popping and adding these children, popping and adding this. So all these children will be added to the queue after all these, right? So I added all these. After that I pop this and add this, pop this and add their child, pop this and add their child. So where they are added after all these values, right? So they are actually doing in breadth manner. So that's why they are called breadth first search. So I will go through all the values and assign a value corresponding to this each element. Okay, assign a value. The value is actually the element or the actual step, the number of steps. So step number. So suppose for 1 4 to 2 4 I have one step. For 1 4 to 2 4 to this 3 4 I have two steps. So 3 4 will contain 2, or 3 4 will be assigned to 2, 2 4 will be assigned to n. Suppose 9 4, 9 4 will be assigned to 1, as from 1 4 and 9 4 I got only one step. For this one I will got this step. So that's why we are assigning the distances, and at last we will return. So somehow I will got this 1 7, right? Somewhere I will got this 1 7. So in that case I will find that I will return the assigned value corresponding to this 1 7, right? So now I will do the code, you will understand it. So this is the rough idea. This is very lengthy problem actually. So let's code now. Okay. So here is a constructor case also. So here I will do this prime algorithm. Look that very carefully. Okay. Otherwise it will look like very magical thing. So here is a prime array. So what I will do is I will yeah. So how many numbers I have given? How many numbers? 9999 numbers, right? Numbers. Yeah. All right. Then I will do. I will fill all the values with true, right? True means 1. Prime with 1, and false as 0. And the prime 2, prime 1. So 1 is not prime, so I will put 0 in place of 1, and then I will start a loop. From here. Up to what I will do, if prime I is not equal to 1, I will continue, I will do nothing. And if it's not 1, what I will do, I will start from that number number I will do, I will put 0 here. Okay. Yeah. Okay. Then I will then nothing. That's it. So now let's create three things. One is my distance array. Okay. Let's just no, it's all right. Let's just put this at 10,000. Okay. And another thing is my visited array. Okay. Then another thing is my queue. So I'm going to make queue as I have said to you already. And I added the queue. Then what will I do? Okay, so this is I want to do these things in another function called BFS. Okay, so public int BFS int source int destination. All right. So I have to do all these things in that place, not here. Okay. So distance of source equal to suppose 0 and visited of source equal to no, not now. So I'm adding element s and I will run a loop until its size is 0. I will pop an element named suppose e. So q dot remove. So if this element is already visited, I will just continue, otherwise mark it as visited. Then what can I do? Yeah, let's you have to change the digits, right? So I have to change the digit. I have to just convert into a string. Okay, so let's convert into a string. After converting this into a string, what can I do? Is now I'm going to do that base first search thing. So I will the part I'm going to do now is to traverse the breadth. Okay, is to traverse the breadth only. So as this is a 4-digit number, so I will start from 0. So I is less than 4 by plus plus, and my characters are 0 and 2 up to 9, right? What will I do is get the string, just copy the original string str, then I will do some operation. I will change that digit, right? So digit is now my character, so I'm changing that. So this is a common technique to change any character in a string. Okay, so just do 0 to I, then plus character, the update the character which I will which I want to update. Okay, so not the character by which it will be updated. Okay, so that character, so plus the substring plus 1. So substring will give me a string from 0 to I. So I have to understand this, that if I change, suppose A B C D, I want to change this character. So this is my 0, this is my I, and these are my rest. Okay, so I will keep this string. So these are 0 to I substring. Okay, this is 0 to I substring because it will not take the ith character, it will go up to I minus 1. So that is the property of string, a substring method. Okay. So what I will do, I will keep 0 to I minus 1, that is writing 0 to I, so it actually keep 0 to I minus 1, then plus my new character. Suppose in place of C I want to give V, plus, so I will give V plus my rest characters, so it will be I plus 1. So by giving I plus 1, it means all the rest characters after I, right? So I plus 1 to rest. So that is why it is working. Okay, where am I? Yeah, now the character is changed, right? Okay, so now let's check that if it's a prime or not. Okay, and the thing is that um, mm, yeah, so I have to check that that the condition that I cannot place 0 in the first digit, right? It will be a 3-digit number then. Okay, so I have to check that. And another thing is that if I want to change 1 3 into, suppose I am trying to changing 1 3 to another number, and I cannot place 1 instead of this one. Okay, so I cannot place 1 here, I have to place like 2 3 0 or something. Oh, 0 I cannot place, right? So except 0 or the character itself, I can place anything, so that I have to give here to change it to another number. So the character, if it is equal to the, okay, so yeah, let's do that here. So if my character is equal to yellow cell is no, so let's do that there. So if my character is equal to str dot caret I, or you can say my I equal to 0, and also my character is equal to also 0, so I am placing at the first place the 0. Okay, so I cannot place that, right? So I cannot do this thing. If this is the thing, I cannot do anything. So to do any, so to do, so not, so to not do anything is equivalent to do nothing, and equivalent to do nothing is continue. That's very good. Okay, right. So then I have to check is my, okay, so I have to convert this into a number. So suppose that number is my val. So I have to convert this number. this is my string, right? I have converted my 1 3 into a string. Now I am again converting into a number after changing the digit. So the process is like this actually. Okay. So now if my value is so my if this is a prime, so if this is a prime, it should be 1, and it should not be covered yet, that is its distance should be -1, right? So then what will do, I will add this, right? So this portion is about the breadth, right? So covering all the breadths and adding them into the cube if they are my actual answers. So what are the actual answers? It has to be a four length number, and it has to be a prime number. Okay, right? So I'll add this value, and sorry, after that I will just return distance of my destination. Okay, so I hope this will work. Let's check. Let's just check this. Okay, so this is right. Okay, so I have to initialize the distance value as -1, right? So -1 represents that distances are not computed yet, right? So I have to just, for this I have to fill. So fill actually fills all the cells of that array with some value. So I have to give the array name and that value. Okay, yeah, and let's do one thing. Let's give the source as 0 initially. It's not visited yet, right? Another thing, oh, okay. So I have to compute the distances also, right? See, I got a number from my initial number, so I have to assign a value to the converted number. What will I assign to that value? Suppose I want to convert 13 into 17. So for 13 I get many options. For all these options I get many options again. So after converting into some number, I have to assign some value. What will be that value? I have told you, right? It will be the distances from the source. Suppose for this one there is only one step I have done, so I will assign 1 to here. For all the values I will assign actually 1. For the eigenvalues I will actually assign 2, right? For the another level values I will assign actually 3. It's like this actually. Okay, so that's why. So I have to assign distance values. So distance means actually the number of steps from the source. So the given number, from the given number up to the current number, I am doing the operations. What are the number of steps I have to do to reach this position where I am currently working? Suppose for this element I am currently working, and to reach the E element from the given element source as S. So what are the number of steps we have done so far? So distance of value equal to 1 plus distance of element. See, we got this element value by changing one digit of whom? By changing one digit of this element E, right? So from E we have done one step further and we got value, right? From E we have done one step further and we got val. So up to e there are may be many steps. So up to e there may be many steps. Suppose x. So up to e means from to convert s to this. So see, to convert s to e there are suppose x number of steps. So that is distance of, that is called distance of e, which is equal to x, suppose. Okay, so I convert e to val by changing one digit, right? So I have done one step by myself now currently. So I have to add 1 to the number of steps e has after changing from s to e, right? So from s to e we have to reach s to e. So from s to e we have done how many steps? This e, right? This will represent the number of steps to reach s to e, and we have done one step further to reach val. So plus 1, so this plus 1 means to reach source to this val, right? So that is why I'm saying. So from source to e we have done these steps. From e to val we have done one step. So the total step from source to val is 1 plus these steps, right? So what we will do, yeah, this I will do. All right, is there anything I'm missing? There should be not. Let's run this. Okay, let's just run this. Errors, we got errors, right? Okay, see, s is already defined. Okay, where it is? Oh, yeah. Here s is already defined, right? Here s is already defined. So I have to do here substring. This is suppose substring, suppose sub answer. Let's this be temp. Okay, so I have to do in all the places. Temp here and also here. Oh, here I have left, right? So I have to return. So what will my BFS will return? The answer, shortest path, right? So I have to just write here BFS num1 num2. Yeah. Let's check now. There is another error. Substring I plus 1 0 to I cannot find symbol. Which symbol? Which symbol it's unable to find? CH str dot substring oh, okay, so here very silly mistakes are. Okay, so we almost done it. Now let's submit this. Just before that, just I want you to look this once again. So this is a constructor, right? So what is a constructor? Which will run when an object will be created. So the object it created is actually in this code. Okay, so there is no code, right? In this code, right? This given code, some object should be created, and when object is created, the constructor actually runs. The constructor runs, and it has no return type. It takes no argument. In that case, there may be some constructor which is called parameterized constructor, which takes values as arguments. So here what we will do, we will just have to do this method, right? So in that method I will initially fill true to all the cells of that array, and then I will uh, uh, start from 2, start from 2, that checking 2 is a prime or not, 3 is a prime or not. So I will create a loop here, and if my cell is true, what I will do, I will give false to all its multiples except this one. I'm saying once again, if my cell value is true, suppose 2 is for true for 2, two, the value is true, put in there, right? So I will put false in every multiple of 2. So 4, 6, 9, 4, 6, 8, all will be false now. Then I get 3 as my next true, because 4 is then false. 4 encountered as false. So I got true, I got 3. So 3 is my new true. So after getting 3 as my new true, I will put false to every multiple of 3, right? So that is why for every multiple, so what is not a prime? The number is not a prime, is obviously divisible by another number. It should be divisible by another number except 1. So the number which is not a prime, it has to be, the number which is not a prime, it has to be divisible by some number. So the number is divisible by some number. So let a number is divisible by some number, right? So it is equivalent to saying that that number which is divisible by some number is multiple of that number. Suppose x is divisible by y, so I can say x is a multiple of y. So the all non-prime values will be my multiple of some number. So all my non-prime values will be multiple of some number. Which number? The prime values actually. So what I am doing actually, this is the thought process while actually constructing this algorithm, that I get a true, I will just put false to all other multiple values of 2. So they never got actually the chance to being a prime number, right? So in case of 3, just put all the values of multiple of in place of multiple of 3, right? So they never got a chance to be a prime number, right? So my 3 is now only prime number. After that 5 is now only prime number, because all the multiple of 5 is gone right now. So all my uh, big options, I don't have to check the multiples already. That is the beauty. I don't have to check them. Okay, so I finished that work while doing for 2. I am creating a loop and doing many works, because for that I have to do many works if I use the old algorithms. Okay, so that is the beauty. So after that I just have done BFS, where I put search the breadth first values and put them in queue, and just calculate the distance value and just return the um, destination distance. That is, so distance of an element means distance of an element from the source. So in how many steps I can reach that element from that source. This is the distance value of that element. Okay, so I hope you understand this. Let's submit it now. Okay, so got it. So let's see you in the next video.